Okay, let's do an introduction into congruence. Let's say that I've got two triangles and I'll try and draw them as accurately as possible. Label the left one triangles ABC, the right one DEF. And first of all, I want to note that we always use capital letters whenever we label the vertices of any shape. And we don't call these corners, we call them vertices. Okay, that's the plural for vertex. Right. Now, let's talk about congruence. Let's say this angle is the same size as that one. Let's say this angle is the same size as that one. And let's say this angle is the same as this one here. And let's say that AB is the same length as DE, AC is the same length as DF, and let's say BC is the same length as EF. So we have a scenario where all the angles are the same size and all the sides are the same length. We would say that these two triangles are congruent. Okay? So they have to have matching size angles, that's angles, and they have to have matching side lengths. And those are the two conditions for congruency. Okay, next thing. Let's say that these two triangles are congruent because they have 6 matching features, 3 angles and 3 sides. That's 6 features that makes the two triangles identical. Well, when it comes to triangles, we actually don't have to have all 6 features proven to be matching before we can call them congruent. For example, let's say that I've got a 90-degree angle there and a matching one there. Let's say this is 45 degrees and this is 45 degrees. I know it doesn't quite look like that, but just go with me. Well, then I can work out that the third one is 45 and this one would have to be 45, and that's implied. That's implied. So really, if 2 out of the 3 angles match, then I can tell without having to calculate the third one that the two triangles have all 3 matching angles. And so we can reduce the number of features on 2 triangles that have to be tested for congruency by looking at these patterns. Here's another one. Let's say that I have side lengths this time, and I'm going to say that this is 5, and let's say this is 7, and let's say this is 6, and I'm just making this up for now. But let's say that I wanted to draw a different type of triangle using 7, 6, and 5 units. Well, I wouldn't be able to. It's actually not possible to draw a second triangle that is not identical to this one if you use the same side lengths. And you can try that if you don't believe me, but it's true. So what we're saying is that there are certain congruency tests that have been standardized, and one of them is if 3 sides match in length, then the 2 triangles must be congruent. And we call this the SSS rule, S which stands for side. If 3 sides match, then it passes the triple S rule, and we can say these 2 triangles are congruent. Okay, here's your second rule. Your second rule is that if you have a pair of matching right angles, and the hypotenuse is the longest side of a right angle triangle. If this side matches that side in length, and you have a second side, and it can be either, then these 2 triangles are also congruent. And it's called the RHS rule. R is for the right angle, H is for the hypotenuse, and S is for the additional side. Okay, let's go to the third rule now. So the third rule says that if you have matching sides and matching angles and a second set of matching sides, then these two triangles are congruent. And this is called the side angle side rule. And very important that this angle is between two sides. So notice side, angle, side, where the angle sits between the two sides. That's called the SAS rule. Okay, the fourth and last rule now. The fourth and last rule says that if you have one pair of equal angles, and a second pair of equal angles, and a side that are equal in length, then the two triangles are congruent. This is called the angle-angle side rule. Okay? And when it comes to this rule, it doesn't matter if this is the matching side, or if it's this one, or if it's the third one, this one over here. It can be either. So technically, I could say that it's also the ASA rule, it's also the SAA rule, but you'll find that all textbooks call it the AAS rule. Okay, so that's our introduction to congruence. Let's have a go at some questions.